Let's get this wire out of the way. Yeah, hi folks. This is the next video for the Year 2 Pure. We're looking, exercise is it? We're looking at 7B using these addition formula. Now remember, just a reminder, we know the special angles. Remember back to GCSE we did sine, cos and tan of 0, 30, 45, 60, 90, and because we knew the shapes we could do 180. I mean, actually we could work others out based on these angles. So we know these are the special angles for which we have exact values. It's not the end of the world if you haven't memorised them, because of course you can use your calculator now. But it is important that we remember these are the special angles that we're going to use, or of course the radian equivalent, but we're working in degrees for all of this exercise, I believe, yeah. So sine 15, and if I want an exact value, it means I need to work in these special angles, because sine 15 isn't a special angle particularly, and the calculator will give me some decimal. If I want exact values, I'm going to have to work in these angles. So I'm going for 45 minus 30. And of course, I can expand out using my addition formulae. I'm going to use sine A minus B, and that equals sine A cos B minus cos A sine B. So sine of 45 minus 30 degrees will be sine 45 cos 30 minus cos 45 sine 30. I could use my calculator or my brain. Root 2 over 2 times by root 3 over 2 minus root 2 over 2 times by a half. So that's root 6 over 4 minus a quarter. No, it's not. That's minus root 2 over 4, which is root 6 minus root 2 over 4, and that's what they wanted me to prove. Now I appreciate that it says in 7b, it says without using your calculator. What it means, I think, is obviously we can use our calculator, but what it means is use the special angles, show that you can get the exact values. I'm pretty sure if you type in sine 15 degrees, the calculator won't give you that. So you don't necessarily need to not use your calculator, but do show your working and show how we get down to that value. So treat question 1 and 2 as show that questions. Example, that was example 5. Example 6. I think we'll have a whole page for example 6. So, example 6, there's a lot to do for this. Sine A is minus 3/5, and importantly, there are clues given when it tells us that A is between 180 and 70. Cos B is minus 12/13. B is obtuse, so remember that means between 90 and 180. Expressions for, find exact values of cos A minus B. Well, cos A minus B is cos A cos B minus sine A sine B. And of course I've got cos B and sine A, and I need to find the others. Now the wrong thing to do here is try to find A and then take the cos of that. Because you'll be rounding, it's 3/5 is not a nice angle. It might be the case that you can do an inverse sine and then take the cos of that, and the calculator's clever enough. But you know, they can easily say show that. So you do need to understand how we get an exact value for cos A without resorting to finding the angle and then taking the cosine of that. And we do this, we use the identity that we know, sine squared A plus cos squared A is 1. So cos squared A is going to be 1 minus sine squared A. Well, that's 1 minus the square of 3/5, 9/25. So cos squared A is 16/25, which means cos A could be 4/5 or minus 4/5, but because there's a constraint on the size of A, let's have a look what that means. Given a cos graph, remember the cos graph starts at 1, it's between 180 and 270, there's my 180, so I'm in this region here, which means my cos of A must be negative. So cos A is minus 4/5. And do the same process to find sine B. Sine squared B plus cos squared B is equal to 1. So sine squared B is 1 minus cos squared B, which is 1 minus the square of 12/13, 144 over 169. So sine squared B is 25 over 169. B is between 90 and 180, so let's have a look at a sine graph. There's my sine graph, 90, 180. So sine B must be positive. So sine B must be the positive root 5/13. So I can now sub in cos of A minus B is cos A cos B. So cos A cos B 4/5 times 12/13. I'm just going to write it out. Minus 4/5 times minus 12. Plus, look, I got it wrong. It is plus. Plus. So there goes the dog. Sine A, sine B. 33/65. To find tan of A plus B, tan of A plus B, well, that's, we're given tan A plus tan B over 1 minus tan A tan B, and of course tan A is sine A over cos A, which is sine A minus 3/5 over minus 4/5, 3/4. Tan B is sine B 5/13 over minus 12/13 minus 5/12. So we could just sub into tan A plus B and get 16 over 63. And the last one, cosec, remember, is 1 over sine. Cosec A minus B is 1 over sine of A minus B. And sine of A minus B is sine A sine B minus No, it's not. Sine A cos B minus cos A sine B. And if we sub the values in, it's straightforward enough. 65 over 56. Okay, a bit of thought, but I think we should be okay with 7B. Let me know if you need anything. Bye bye.